Okay, so I'd like to thank everyone who is joining today. Welcome to today's CNCF webinar, End YAML Engineering with cdk8s. I'm Christy Tan, Marketing Communications Manager at CNCF. I'll be moderating today's webinar. We would like to welcome our presenters today, Elad Ben Israel, Principal Software Engineer at AWS, Developer Tools, and Nathan Tabor, Senior Product Manager at AWS Kubernetes. A few housekeeping items before we get started. During the webinar, you are not able to talk as an attendee. There is a Q&A box at the bottom of your screen. Please feel free to drop your questions in there and we'll get to as many as we can in the end. This is an official webinar of the CNCF and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of that Code of Conduct. Basically, please be respectful of all your fellow attendees and participants and presenters. I'd also like to remind folks that the webinar recording and slides will be available later today at the CNCF webinars page. That's cncf.io/webinars. With that, I'll hand it over to Elad and Nathan to kick off today's presentation. Take it away.
Hey, good morning, everyone. My name is Nathan, or Nate Tabor. I'm a Senior Product Manager here at AWS, and we're really excited to be talking to you today about how you can end YAML engineering with the CDK for Kubernetes, or cdk8s. So as we get started here, let's actually give a quick introduction to who we are. So my name is Nate. Like I said, I'm a Senior Product Manager here on the AWS Kubernetes team. I've been working on Kubernetes technologies at AWS for just about 3 years now, including a lot of involvement with our managed Amazon EKS service. And I'm joined by my friend and colleague, Elad Ben Israel. And Elad, I think you're on the line. Go ahead and introduce yourself.
Hey guys, nice to meet everybody. Thanks for joining us. I'm Elad, calling from Tel Aviv. Actually, first time in the office after 2.5 months. It's very weird. I can actually sit down in the open space and speak because there's nobody here. I'm the only one. I just didn't want my kids to be on my laps during the during the presentation. I've been at AWS for over 5 years now, and in the last 3 years, I've worked on the AWS CDK. Super excited to be here. I'm really hopeful that this would be interesting for you guys, and curious to see what you guys think.
Awesome. So I think that's a good intro of what we are, who we are, and what we're doing here. And I think what's exciting is that we have a brand new project to share with you today. So I know a lot of times these slides and these demos, they can wax on for, a long time about, why we built this and how awesome it is. And then you never really understand what we're actually building. So we want to just start off right away this morning and tell you about the Cloud Development Kit for Kubernetes, or the cdk8s. And this is a brand new project that we've been building at AWS for the past few months, and we're really excited to be showing it off in the world for the first time today. And there's 3 important things that we think really cdk8s helps customers with. So first of all, cdk8s is a software framework that lets you go from code to config. So using cdk8s, you can define Kubernetes applications and architectures using familiar programming languages and generate well-formatted YAML for your applications every time. This lets you effectively reduce or completely eliminate the need to copy and paste a template, to do what a lot of folks refer to as YAML engineering. Using cdk8s, you can turn the best practices for how you define your Kubernetes clusters and applications into code libraries and share them easily with your teammates across your organization or in the larger community. And so we think this is a really powerful way that people can be able to share different paradigms and best practices for their Kubernetes clusters. And then finally, and we think this is a really important point, and I noticed there was a question on the Q&A right in the beginning, which is like, why is this interesting to the community? Why are we here on a CNCF webinar? And it's because cdk8s is a project that has been started by AWS, but it's not for AWS. cdk8s is for everyone. It runs locally and it generates Kubernetes YAML that you can deploy to any cluster anywhere. And this lets you standardize across on-premises and any cloud. So let's talk a little bit about YAML. I know that YAML is, first of all, I think that the best place to start here is that we think YAML is awesome. And obviously we use YAML everywhere in our lives. Kubernetes uses YAML everywhere. It is the data configuration and definition layer for Kubernetes clusters. It also happens to be the way that we do a lot of things at the AWS cloud. And so using YAML and being involved in YAML is tried and true for us. And we think YAML is awesome because it's easy for humans. It's easy for humans to read it and to understand it and to use it in a simple way. It's universal. So, you can use YAML across like almost every system for declarative state. And it really does a great job of being declarative, of representing the desired state of a system. And that's part of the reason why we all love it as part of Kubernetes, is that I can represent the desired state of my system and then use the state machine within Kubernetes to actually help bring that system to the desired state. What are the downsides of YAML? Well, it could be a downside or an upside, depending on how you see it, is that it's also very static. And this is interesting because it means that YAML is very easy when you have a few things to declare. So if you're declaring a simple web app or a few services on your cluster, maybe just setting up a config map, then YAML is really straightforward. It's easy to just quickly open in a text editor. You don't even need an IDE. You just open Vim in your terminal and away you go. But as you grow, as you start to run lots of apps on your cluster, as you grow Kubernetes usage across your organization, YAML can get really, really hard. And we also see this especially when Kubernetes, the job of defining and managing applications in Kubernetes gets passed down from operations teams to development teams. And so when developers start taking over management of the clusters, then they have to do a lot of things that there is not necessarily like intuitive to them with the way that they write code today. So they have to do a lot of boilerplate. And Kubernetes has a lot of boilerplate, and that boilerplate exists for very good reasons, but it adds complexity and it opens up room for errors. And developers have to implement a significant amount of this, making sure they get the right API versions, the right metadata, that they're getting, all the tags and the labels to link different components of the definition together just to get the application running. It also means that sharing can be pretty manual. There's a lot of copy and paste. You start with off-the-shelf examples, either from a vendor or a community repository or from inside your company, and then you have to fork them, you have to copy them, you have to paste configurations. If you're like me, then you probably find yourself opening up the Kubernetes documentation and finding like, oh, what's the right way to how should I define this persistent volume claim properly, and like copying and pasting things in and like making sure that it works, right? And there are tools like Helm that kind of help to package these things together. But at the end of the day, these are systems that are built around making it easier to copy and paste and kind of combine different YAML files. It's not fundamentally solving the issue. And that kind of gets down to that, maintaining these files can take a lot of manual work. Once you've copied or forked configurations, there's not really an established model for distributing the changes made by the source to fix bugs or do security patching or migrate applications to new versions. You really, even if you're using a tool like Helm, you have to understand what's going on at the base level within the YAML, what's actually changing in order to ensure that changes are applied. And that often means that, you have developers deep diving through all these YAML files, trying to figure out, did I change the way that this application is defined in every place properly? And because developers have to manually modify this YAML at its lowest level, it means that there's an inability to express business logic within the application definition. Without, you have to do things like start building custom controllers, using templating engines, or implement other techniques. So, it's not that all of this stuff is not possible today. It certainly is. It's just that it's complex. And for development teams that are really focused on, driving innovation and writing code and delivering that code to their customers to drive innovation, it takes a lot of time and it takes a lot of extra effort that they don't always want to do. And this is something that we've heard a lot from customers. And then finally, we'll talk a little bit about this, is that, it's hard when you start implementing all these other tools for managing Kubernetes YAML to get a unified workflow as a developer. So developers are writing code in common programming languages, and then they're deploying that code, they're building it into containers, and they're deploying it to their clusters with CI/CD. And Kubernetes applications, in the traditional sense, are defined with YAML data, and then they're deployed manually with kubectl. And so this means that, you know, you have effectively two workflows for the same process, and that just gets difficult. So let's talk a little bit about general purpose programming languages. General purpose programming languages are what developers are writing in, so they're familiar to them. The downside to general purpose programming languages, and again, it's not necessarily a downside, it's just the difference, is that they're specialized. They do different things for different people, and you use different languages for different tasks. So depending on what kind of things you're writing or what kind of things you're building, you're going to be more or less familiar with a different set of languages. So, you know, in the Kubernetes community, there's a lot of people that are very familiar with Golang. In the data science community, you're going to find lots of people familiar with Python, and et cetera, et cetera. These languages are also imperative, which means that traditionally they're not super great for actually defining the state of a system, but they're really good for like defining, you know, business logic and you know, complex dynamic, you know, dynamic applications that you need to write. And another great thing about these general purpose programming languages is there's a lot of tooling and there's a lot of workflows built around them. There's a really great canon for most well-established languages that makes it easy for developers to kind of, you know, build libraries, to build abstractions on top of languages and kind of get a lot of power out of the languages. And effectively, you know, it's the amazing benefit of scaling applications larger and larger and people being lazy. You don't want to have to go and dive through and re-implement everything over and over again. You want to be able to reuse code and you want to be able to move quickly, and it doesn't make sense to do a lot of things over and over again. So there's a lot of great tooling and things that you can do in general purpose languages that you can't necessarily do in declarative YAML. And that's really where we came to the idea of the CDK for Kubernetes. The CDK for Kubernetes bridges imperative languages with declarative YAML. And so one of the criticisms, you know, there are ways to use imperative languages on Kubernetes today. So for example, you can write custom controllers in Go that directly call the Kubernetes API, but this actually is harder for most people to implement because you have to own the state machine, and it's hard to define state in a complex system like Kubernetes. The you know, established community tooling for defining state and maintaining state, so tools like kubectl, for example, are very good at holding the state within the system and bringing that state to a desired place. And so re-implementing that logic as a developer actually is really daunting unless you're an expert. And I'm sure we have some experts on the call that have done this before, and but the reality is that the majority of people, especially as the Kubernetes community grows and more developers who are less familiar with Kubernetes begin to adopt it, this is a daunting task for them to take on if they just want to get the advantage of imperative language definition. So cdk8s gives you both. It simplifies the writing process and allows you to produce best practices YAML for configuring your cluster and applications. And that's one of the things that we think is so amazing, is that it lets developers easily define Kubernetes applications using familiar programming languages. So today we support JavaScript, TypeScript, and Python. And in the future, we're thinking to support Go, .NET, and many more languages. So we really see this as a general purpose tool set for customers to come in and use the languages that they prefer to define Kubernetes in a standard way. The other benefit here is that it lets you compose and share components of your application through code libraries. And we think this is awesome because they're easier to maintain, they're easier to update, and you can use cdk8s to really standardize how you define Kubernetes across your organization. And in a few minutes here, Elad's going to actually give us a demo of how that looks. But really what it comes down to is that when you're running Kubernetes, if you're on, like, for example, a central operations team at your organization, and you want to define how all the developers across your organization run standard web apps. So you want them to be configured to use certain ports, to use load balancers in a certain way, etc. You can actually define a code library in cdk8s that says how that happens, and then developers can simply call that code library as a class when they define their particular application for Kubernetes. And the library will make sure that all the best practices that you think should be followed actually are included when that application is defined. And then finally, cdk8s lets you simplify application workflows by using the same tools that you use to build and define your application code as you use to build and define your application configuration. So if you use cdk8s with a GitOps workflow, for example, you can write your application and its configuration in code using the same tooling and the same languages and the same tool set, and then you can deploy all of that through CI/CD pipelines to your cluster. So for example, you would deploy your application code through a build pipeline. Maybe you're using something like Jenkins that would build your container image and put it in a repository and then deploy it out to the cluster. And then you would use the cdk8s to actually generate the YAML. Then you'd put that YAML into a Git repository, and you'd use a tool like Flux, which is part of the larger Argo project, which is also a CNCF project, that would then go ahead and take the YAML that's in that Git repo and make sure that that desired state is applied onto your Kubernetes cluster. So that's all I have right now. I think we've had a lot of time here to kind of talk about, what is cdk8s and why is it awesome and why are we so excited about it? Let's go ahead and actually see it in action, because this is the best way to get a feel for what we built and how it works. So I'm going to go ahead and hand the screen share over to Alad. Alad, do you want to go ahead and take it away?
Yeah, sure. Thank you. I hope this is a good size font, right? Okay, so yeah, I think the best way to actually understand what we're doing is to show some code, because this is basically what this is about. Just one more word about the background. So as we said, this project stemmed from our work on the AWS CDK. And for those of you who are not familiar with the AWS CDK, it basically solves the exact same problem in the AWS CloudFormation space, which is the provisioning engine for AWS resources. And we've been working on this project for about 3 years. It's been a year since we launched it at GA, and maybe over 2 years since it's been out. And we've had many, many learnings during that time, but continued constantly to reinforce the main value proposition of allowing developers to define infrastructure or define systems through object-oriented programming, because object-oriented programming is a very, very powerful tool for modeling systems. The only problem is that we couldn't apply it to the space of infrastructure definitions and Kubernetes, CloudFormation, Terraform. And the CDK has this model we call the constructs programming model, which basically enables you to bridge that gap. And I'm going to show you exactly how it works. So I spinned up a new cdk8s project. What I've done, I just don't want to spend time on doing that right now, but what I've done is basically we've got a CLI that you can install through brew or through npm. And it's a pretty minimalist CLI. It doesn't have too many things right now. One of the things that it can do, it can help you initialize new projects. So you can do cdk8s init, and then currently we support Python and TypeScript. And it'll just spin up a project like this one that has a main entry point function, some configuration. It's basically pretty straightforward and pretty empty. And what you see here is the main file, basically the entry point for your CDK application. Now, I mentioned constructs earlier, and I want to talk a little bit about constructs and what they are. So the idea behind constructs is that they represent a completely abstract entity in the world. They don't have to be backed by anything. And so, for example, the root, and they create a tree. And so the base of your application is the app construct. And within the app construct, you then define other constructs scoped together under the tree. And so let me give you an example. In this case, we have an app and it has a single chart. We use the terminology chart from Helm to represent basically a deployment unit in the cdk8s project. And you'll see that charts basically translate into a Kubernetes manifest. And so we have an app here, and it has a single chart called typed mark chart. The name of the chart is hello cdk8s. Now, if I do cdk8s synth, it'll basically synthesize a Kubernetes manifest from my chart. And as expected, this is an empty manifest because my chart is empty. So first things first, let's just add a pod, right? I think like we can't do anything without just creating a pod. And so what I did here, let me repeat that for a second. I basically created a new object, and you saw that my IDE actually helps me by showing me all of the classes that that work with this. Basically, it helps me with auto completion. And you see, once I've added this pod, it added an import for me that contains a module that has all the Kubernetes APIs. Let me just jump into this file for a second. You see, this file is generated by cdk8s, and I'll show you, at the end, I'll show you how to generate these files. But it basically contains all of the Kubernetes core objects as strongly typed classes with annotations and documentation. So it's based on the OpenAPI documentation of OpenAPI spec of Kubernetes. So it's one-to-one with the Kubernetes API and has all the capabilities of Kubernetes. It's low level in that sense, but it still gives us the ability to use a programming language in order to define these resources. Now, I've created a pod instance, and every construct in the CDK world, the AWS CDK also has the same pattern exactly, except 3 parameters: scope, name, and options. Scope and name are basically the parameters that allow the construct to be defined within another scope. And that's actually an important capability. You will always specify this for scope because you always define this, the pod in the scope of the chart in this case, or you'll see that it's possible to create custom constructs. And so you'll always define the children of those constructs under the parent. And then I can specify a local name for this pod. And that is very different from how you define Kubernetes manifests, where you specify namespace global names. Every name in the Kubernetes, every resource name in the Kubernetes world is confined within the namespace, but it has to be globally unique within the namespace. cdk8s offers a client-side namespacing that uses constructs. And so in this case, I can specify the name of my pod. So I'll just call it pod info. I'm going to use the pod info image to demonstrate how pods are created. And then the last parameter of all constructs is always a set of options that are specific to the construct. And so if I look at the options that the pod has, this is the classic Kubernetes API. As I said, this is generated from the Kubernetes API. So there's nothing special or new here. So okay, let's see, what do I need to specify for spec? Obviously I need to specify containers. And you see that my IDE helps me. And so I wanted to find a container. My IDE tells me, okay, I need to specify a name. Let's call it hello. And then image. I'm going to use the pod info image. I've got a cheat sheet here. And I'm going to expose, the pod info port, which is 9890. So this is basically the simplest configuration I can do to basically deploy a container in my Kubernetes cluster. Now, I have a cluster here. I actually use kind, which is pretty cool. It's a local cluster. And as Nathan said, there's nothing special about cdk8s in the sense that it supports every Kubernetes installation. It's not specific to any installation or any cluster. Okay, let's start by synthesizing my template, my manifest. And as you can see, this manifest now contains a single container. And this is pretty straightforward Kubernetes configuration. You know, for those of you who use Kubernetes, that's probably not news or anything, but for people who come into Kubernetes, having IDE support, having auto-completion, having all this help in their familiar programming language is where cdk8s is targeting, basically. Okay, so I've synthesized my manifest. And now I'm just going to apply my manifest onto my cluster and see the container is creating and it's running. Let's see if it even works. Port forward. Let's see if that works. Cool. So we've got pod info here. Okay, what's next? Everybody that taught me Kubernetes always told me never to use pod because pods are ephemeral, they go away, you can't control them. So you need to use deployments, right? Okay, so let's refactor this code a little bit. I'm going to create a deployment resource. And the spec for deployment resource is a pod template, so I can just like this pod template. And again, this is fully strongly typed. You can see all of the APIs of the deployment pod template over here. I basically want my this, right? And what else do I need to specify? Oh, I need to specify selector, right? And so now in classic Kubernetes engineering, you'd basically specify some string here that would match the labels that you put on the container. Now, I still want to do the same thing, but now I can use tools from the programming language space, right? I can use something like constant. This is my pod info app. Let's create a label. Let's create a label here. And I'll say selector has to match this label. And in my container, I'll just basically specify this label here, which is, you know, might seem trivial, but it's not trivial when you have thousands or dozens or hundreds of files like this, and you need to synchronize these labels across, you know, different resources. So I'm sure some of you have had these challenges, and so here all I have to do is just use a constant, right? It's very straightforward. The other thing that I can do is probably specify, you know, replicas. Let's say 3. Okay, so before I continue, let me kill my pod. Good. And then I'm just going to run synth and apply again, right? It's basically my little iteration cycle. And you see that now I have 3 pods and a deployment, and you see that my little manifest has a deployment here with all this information that I wrote. Cool. Now, in order to access this, the next thing is to add a service, so we can do that pretty easily. But you know what? Before I'm doing that, it feels like redundant, right? Like I've been doing this for a while, and every time I go and define a Kubernetes application, I always end up with these couple, you know, service and deployment, and then I end up with a horizontal pod autoscaler and an ingress controller, and like these patterns are constantly coming back to me. And so, as Nate said, one of the value propositions of CDKs is the ability to take these constructs, write these custom constructs, and basically share them as normal libraries. And so I want to show you this library that we've been working on with a developer advocate from AWS, Tori. It's called cdk8s deboer, because it's basically Kubernetes without the boring parts. And it's on GitHub. It's actually published. I just saw that it's actually published to NPM and Python. Let's see if I can find this guy. Yeah. It uses the same technology that we use in cdk8s to create multi-language libraries. This technology is called JSII. And so it's very easy to create these multi-language libraries. So you can use it either in Python or in TypeScript or in Java or .NET, which are the languages that we currently support. And so what this does is basically gives me a higher level abstraction. it doesn't, so I don't care about deployments. I don't care about services. I don't care about hot HPAs. I just want to deploy my app, right? Like this nice little app. So let's install this module and see how to use it. Okay, I'm just going to go and do npm install cdks deboer. Just an npm module, and as I said, you know, it could be Python or Maven, or it could be your internal repository for sharing internal patterns. And import it here. And indeed, I have a deboer app construct. So let me get rid of this. I don't want this. I don't want this. Okay, new deboer app, deboard. And we'll still use pod info. Now, image is required, which makes sense. And let's see what I have here. So I can set up auto scaling. I can just say true here, and we'll see what happens. I can specify the container port, which is what I do need to specify here, because the default is not what I need. Default traffic is 5. And I can specify resource requirements. And I can also specify ingress. Let's see what this is about. Ingress type. So this guy has 3 options. Cluster IP service load balancer. Those are the classic service ones. It also has an nginx ingress. So it basically creates an nginx ingress controller for me. And Toriel also told me that he plans to automatically add all the nginx configuration. So you can basically automatically, it'll automatically do everything you need to do in order to create an nginx ingress support. But I'm gonna use cluster IP because I have this local cluster here, so I can't even use a load balancer. Okay, that was pretty straightforward. Let's do this again. So first of all, you see that it created a new set of services in deployment. And if I look here, it just did all of that cruft for me to create the service, to connect it. You see that it also created a unique selector for my application and matches those together, which is a detail that I really don't care about at this level. And then if I do kubectl get all, obviously I'm going to have my old deployment here because I haven't deleted it, but you'll see that this one is the service that deboer created for me. Now, last thing I wanted to show you in this example is, let's say I'm adding an auto scaling here. And so if I do this, and I deploy again, you see that it also included an horizontal autoscaler for me, which with some sane default configuration that I guess makes sense. And you can even see that it's actually active, right? Like it'll automatically create my set of cluster, a set of pods based on the scaling configuration that I have here. So this is components, right? I think the interesting thing is if you look at this thing, it's actually a pretty straightforward thing to write. So let me just jump into this code for a second, just to give you a sense of what it means to create these types of abstractions.
So Elad,
yeah,
Elad, there's actually a really good question as you do this from Andreas about like maybe something to talk through here is that how is this built, and how do we achieve multi-language support from a single code base in this library?
So let me show you this project called JSII. I won't get into like the deep details of it. It's something that we built as part of the AWS CDK in the past 3 years. But basically JSII is a technology that allows us to take a library written in TypeScript. TypeScript is the source language for JSII, and package it as a library in every one of the supported programming languages. And the details are here. maybe if we have some time at the end, I'm happy to like dive a little deeper, but it's a pretty interesting project, totally cool and magical in some ways, but also very pragmatic and does the job in another way. So again, I'm happy to like dive in maybe at the end. So we've been looking at this. I just wanted to like just give you a sense of what it means to like write this deboard app, okay? So this is the code. And you'll see that basically deboard app is a construct. So it extends the construct base class. And it accepts a set of options, which is a simple interface, simple struct here with documentation and defaults and all that good stuff. And then it's very straightforward code. So you can see that what it does here basically creates a deboard deployment, which is another construct. And as I said, constructs can form a tree, and so you can compose them together into higher and higher level abstractions. So it instantiates a deboard deployment, instantiates an exposable. And so those two are internal constructs that this guy is using. And you see that each one of them has some configuration, and then based on that configuration, eventually it instantiates the k8s deployment or the k8s ingress or the k8s service, right? Like it basically instantiates these constructs, these low-level constructs that we've used earlier, right? The ones that are like pod, for example. And that's a really important point about cdk8s. Well, at this point of the project, we're very early on. We're at this point, we're basically just laying the groundwork of the first layer of the ecosystem for this. And so the first layer of the ecosystem is the ability to use the core Kubernetes objects. And so those are the imports that I showed you earlier. And I'm going to show you a little bit more about imports right now. And the other thing that you can use freely is custom resource definitions at the base layer. And so to do that, cdk8s is bundled with the command called cdk8s import. And what this command is doing, it basically currently supports only it only supports custom resource definitions and the Kubernetes APIs. You can see that you can either import k8s, you can import k8s at a specific version, or you can specify a YAML file for a CRD. You can even specify a URL for a CRD. I have an example here for the Jenkins operator CRD. So let's try and use that. Basically what I'm doing now, I'm importing the Jenkins operator, and you'll see that it created another file under the imports directory for me that contains constructs for the Jenkins CRD. And so it takes the CRD, it looks at the schema, and it basically generates the constructs for me. And if I do new Jenkins, and I look at this, you see that I basically now have strongly typed API to interact with the Jenkins operator. And this works in both supported languages. It works in TypeScript, it works in Python. We will also support in the rest of the programming languages that we support. But as I said, this is the base layer. These are what we sometimes call in the CDK world, we call those L1s, layer 1 constructs, because they basically map one-to-one to the configuration space. And so in our case, those Kubernetes APIs map one-to-one with the Kubernetes resources. And the CRDs map one-to-one with the CRDs. Above them, we can start building higher level abstractions. So deboard app is an abstraction that basically composes together these L1s into something bigger. And obviously the sky's the limit in terms of what you can compose together and how complex you can get in that sense. And that's one of the reasons we have this concept of scoping and namespacing, because this deboard app, I can instantiate 5 deboard apps into my project, and I have to make sure that the pods or services or deployments or ingress controllers that are defined inside this deboard app are not conflicting with the ones that are defined in this deboard app. And obviously you can also use namespaces. You can do something like say, hey, I want this chart to be in this namespace. It'll automatically, basically automatically, let's do this for a second. Now it'll fail because I don't have the namespace, right? It'll yell. For some reason, maybe. Okay, could be a bug. So yeah, that's I think that's it for me. I don't
So
have anything
actually,
else.
yeah, there's some really nice questions here that we're getting around, importing modules, less about modules, but more thinking about, how can you import CRDs? How can you import different versions of the Kubernetes API? I don't know if we covered that in the beginning here, but we have a few questions live about it. And I'm wondering if you want to quickly kind of show off the CDK CLI.
Yeah. So this is what I actually showed right now. I showed how import works. I showed how to import a CRD. The CDK has this configuration file called cdk8s.yaml that you can also specify imports over there. So for example, I can say, I can add this guy here, and then whenever I do cdk8s import, it'll automatically download the CRD and import it from that location. And I can also specify the Kubernetes version over here. So if I do now cdk8s import, now you'll see that the APIs that I have here, one thing that's changed recently. Yeah. So you see this one is actually 1.16, started from 1.16. So it'll automatically import these. And I can even specify specific API versions for specific kinds if I want to use them instead of the ones that are the default. There's some default resolution for API versions. Does that answer your question?
I think that's awesome. I just have a few things to wrap up here. So why don't we just go ahead and wrap up, and then we can take a few questions at the end.
Cool. I'll stop sharing.
Okay. Let's see. Okay, how does that look? So pretty good? Okay, awesome. So Elad, does that look okay?
Yeah,
Make sure you can see my screen. Okay, perfect. So awesome. So first of all, amazing demo. Really cool to see the power of CDK for Kubernetes in action. And I know it's like drinking from a fire hose. There are so many things you can do, and it's really it's a very open framework for how you can define and build your applications. And I think that's actually one of the most awesome things about it. And we have some amazing questions here already in the Q&A. We've tried to answer a lot of these over chat. We have a few I want to make sure that we answer live here. So I do want to make sure that we kind of cover some very important salient points at the end of the webinar. So this is day one for us. We're announcing that CDK for Kubernetes is alpha today, and we have big things planned. So I know there's been a lot of questions about, is this going to become a CNCF incubating project, et cetera. We can't predict the future. Obviously, that would be really cool, and there's a lot of places we can go in the future in terms of CNCF. I think where we are today is we'd really like the community to try this out. We built this for the community. We're excited to give this to the community. We'd love to see this develop and to grow. Obviously, our wildest dreams is this becomes a CNCF sandbox project in the future, but we're not going to jump the gun here. We're just in an alpha stage, and we're excited to kind of see what people think and to evolve this project over time. And I'll kind of skip down here is that, we built this for the entire community. We built this so it can work with any cluster anywhere. We use the same concepts and the same construct model that we use to build the AWS CDK for AWS APIs. But, I think it's a really important point that we want to stress is this is not a project for AWS. This is a project for any Kubernetes cluster running anywhere. And we're excited to see what people do with this. And I know there's already been a few blogs from some very early folks that were involved in the project about, using this to deploy applications to GKE, and some people are using this to deploy applications on-prem. And we actually think that's fantastic. We're super excited for that. And and we're excited to see customers use it everywhere that they run Kubernetes. Like Elad said, today we're supporting Python, TypeScript, and JavaScript. We will be adding support for more languages, including Go, Java, and .NET. These are on our roadmap. We'd love to support more. There's some questions about, what are the most popular languages? Again, very early days for us to know that. I think that that's where we're looking to all of you, and we're looking to the larger Kubernetes community to tell us, like, what do you want to see? Like, what makes sense for you? What are you writing in? I highly doubt that we will support every single programming language that is in use today. There are just so many, and I don't think that that's the right approach. But I think that we want to make sure that we are supporting the common languages that people are using, and if people are using it, we want to make sure that we have good support for it. And then finally here is that we love contributions. This is an open source project. This is a project that we really want to grow together with the community. And so, join us, open an issue, open a pull request, add something to our roadmap, or, request that something gets added to our roadmap. And we're public on GitHub here. So we would love your input. We would love your feedback. We'd love your contribution. And so with that, let's go ahead, and we have a few minutes here for questions. I know we have some awesome questions that are in here. Maybe we should start with the questions about Helm charts, Elad, because we have a few that have been coming in.
Yeah, so we'd like to do that. We'd like to be able to import Helm charts. One of the challenges with Helm charts is that there's no specification besides the values file and a big README table. There's no strong specification of the interface. And so that's one of the things that we're trying to figure out, what's the best way to actually provide that support. Obviously it's going to be super easy to support non-typed classes, basically object or any, but we'd like to do more than that because that's one of the biggest values. So we'll see. But yeah, that definitely planned. Maybe the other question was about testing framework. I can answer that quickly. So basically you can use any testing framework. We use Jest snapshots as a pretty robust and cheap way to perform testing, because one of the interesting things about constructs in general and cdk8s specifically is that their CDK application is almost purely functional. You execute it and it produces a result. There are almost no inputs, right? It's basically a function that always produces the same result. So testing it, and constructs, may have an interface. And so testing these things is actually pretty straightforward. You feed the construct some inputs and you check the synthesized output. That's the terminology we use. So yeah, testing using snapshots like Jest snapshots, if you're familiar with those, is very powerful. And with the AWS CDK, we also have this tiny little test helper that lets you write assertions against the synthesized output. So you can say, I instantiate this construct and I'm expecting this property to have that value in the synthesized output. So I think that maybe we'll be able to extract some commonalities from the AWS CDK into a separate library. So that's something that people will be able to use here as well, or we'll create something here that's dedicated for Kubernetes. What else?
There's a lot of questions. There's a few questions here about Pulumi. I'll just really briefly answer this because I just typed a response to one, and then I had another one came in. So I think I'll just say live what I just responded to Warren, which is basically we're well aware of Pulumi. We think it's an awesome company and a great team. We know it has some similar concepts to cdk8s. To be honest, we haven't really focused on it. And we built cdk8s in response to customers telling us that they would like an easier way to enable their development teams to define Kubernetes applications. And based on the large amount of positive feedback that we received for the AWS CDK, And so really where this is built is from, customers asking us and talking to us about their needs. And we wanted to bring that same awesome experience that AWS CDK users have out to all Kubernetes users. And that's really, really why we built this. And that's like just a really important part of how we build things at AWS is we start with the customer and we work backwards. And so when it comes to competitors or other solutions in the space, we haven't really, that's not really our focus. And we're really excited to, bring this out to customers and to provide a solution that we think will work for a lot of people. There's an awesome question from Andres on the architectural concepts and how to structure projects.
Yeah. So basically the point is that since you can use any programming language that you want, you go back to the principles that you're used to when you organize your projects and organize your architecture, organize your system. One of the things that I like to suggest to people is to separate the constructs and charts in the Kubernetes world, in the cdk8s world. And so my recommendation is to basically define your entire application in constructs, pure constructs, basically classes that extend the construct base class. Constructs are not just for reusability, they're also very powerful as an organizational tool. And then you can basically compose these constructs into charts based on your deployment needs. And so you can say, let's take these constructs and compose them into a chart for my development environment and configure them in some way. So I'm creating a bunch of constructs and configuring them for the development use case. And then I can also compose them together for my staging environment and compose them together into my production chart. And this way I can basically reuse those application parts when I define my deployment story, right? A chart is basically kind of like a deployment story already. So that's something that I can talk about. But I think we'll learn. This project's very early, and I'd like to see what people are doing with it and how people are, using it. And I think we'll be able to provide a bit more guidance in the future. Does that answer the question? I don't know. I hope. Yeah, there's another question about multiple projects in the same repo. Again, there's nothing opinionated in cdk8s about how to organize your project. The projects that cdk8s creates are simple, straightforward projects in the programming language that you decided. You can do that manually if you want. There's nothing special for us. And so you can define all of them in a single repository or multiple repositories, or publish them to internal package managers and consume them as libraries, depending on your, on the team and the company and the use cases, technology.
Awesome. Well, I know we're getting close to the top of the hour. So thank you again, Elad and Nathan, for your presentation today. It was super great. I'd like to encourage folks to connect with Elad and Nate on Twitter if you have further questions. And a reminder that the recording and the slides will be available later today for download and other ways that you can connect. Again, that's all the time that we have for today. Thanks again for joining. We look forward to seeing you at a future CNCF webinar, and have a great day. Thanks, everyone.
Thank you,
Thank
guys.
you, everyone. Thanks for coming.